Let us solve numerical on OC and LC test. So given numerical is a 12 kVA 220 volt oblique 440 volt 50 Hz single phase transformer gave following result. No load test result is 220 volt 2 ampere 165 watt. LV side, that is test is conducted on LV side. Short circuit test result is 12 volt 15 amperes 60 watt HV side. The test is conducted on HV side. So draw equivalent circuit referred to LV side. Show components value. Find secondary terminal voltage on full load at 0.8 power factor lagging. So this is what 220 oblique 440 volt transformer. So LV and this is what HV. LV side here is primary and of course it will be secondary. So from OC test we know W naught equal to V naught I naught cos phi naught. So based on that I will find phi naught directly. Phi naught will be cos inverse W naught. So what is W naught? 165 divided by 220 V naught and I naught into 2. So if I do calculation, it will be cos inverse 165 by, so it is coming as 67.97 degree. So circuit parameters are, we know they are exciting branch circuit parameter and equivalent impedance referred on any side, right? So here R naught we know, R naught is given by V naught by IC and X naught is given by V naught by IM. So we must find IC and IM. We know IC is I naught cos phi naught. So putting this value, it will be 2 cos 67.97. It comes as 0.75 ampere, and IM will be I naught sin phi naught, same value with sign, so it will be 1.854 ampere. We got IC and IM, therefore we can calculate R naught and X naught. So R naught will be, V naught is 220, right? V naught is 220. So V naught 220 by what is IC is 0.75, so it comes as 293.33 ohm, and X naught will be 220 by 1.854. It comes as 118.66 ohm. So we got two circuit parameters from no load test, which are R naught and X naught, and OC test is conducted on LV and LV side is primary, so these circuit parameters are of primary side. Now SC test, it's conducted on HV side and HV side is secondary side, right, in this numerical. Therefore we will find equivalent circuit parameters referred on secondary side. So by magical formula ZE2 we know ZE2 is VSC by ISC cos inverse WSC by VSC ISC. So putting these values, ZE2 will be VSC is 12 by 15 cos inverse 60 by 12 into 15, so it comes as 0.267 plus J 0.754 ohm. So we got Re2, therefore Re2 is 0.267 ohm and Xe2 equivalent leakage reactance referred on secondary side is 0.754 ohm, right? So if I have to draw a equivalent circuit referred on one side, that is primary or secondary, so I have to transfer either secondary side parameter on primary or primary side parameters which are R0 X0 on secondary. So let me transfer them on primary side. So for transferring, we know refer to primary, so Re1 will be Re2 by K square and Xe1 will be Xe2 by K square. What is K? Is transformation ratio, that is 440 volt by 220, it comes as 2. Therefore Re1, if I put value 0.267 divided by 4, so it comes as 0.0667 ohm and Xe1 comes as 0.754 divided by 4, it comes as 0.188 ohm. So we got circuit parameters, therefore circuit can be drawn, equivalent circuit. So this is what equivalent resistance and this is equivalent leakage reactance, and we will have exciting branch also. There is say load. This is Re1, which is how much? Re1 is 0.0667 ohm, that is Re1, and this is Xe1, it comes as 0.188 ohm. The voltage here is V2 dash because circuit is referred on primary side. X0 we got as 118.66 and R0 we got as 293.33 ohm, and there will be V1. Now what they are asking, find secondary terminal voltage on full load 0.8 lagging power factor. So if I know the drop at 0.8 lagging power factor, voltage drop at 0.8 lagging power factor, so I can find it referred on primary or secondary. So on referred on secondary, it will be I2FL Re2 cos phi plus I2FL Xe2 sin phi. Cos phi is 0.8, sin phi will be 0.6. What is I2FL? It is secondary full load current. So I2FL can be calculated at, it is 12 kVA transformer divided by 440, so it comes as 27.27 ampere. Therefore voltage drop will be 27.27. I will take I2FL common, and in bracket Re2 it is what, 0.754. cos phi is 0.8 plus XE2 was 0.267. Sorry, RE2 was 0.267 and XE2 754 into sin phi, that is 0.6. So it comes as 18.16 ohm. Sorry, this is voltage drop, so it is volt, right? So this is voltage drop which is also given as E2 minus V2. So if they are asking terminal voltage, secondary terminal voltage will be what? V2 minus V2, that is E2 minus drop. What is E2? That is 440 volt minus drop is 18.16. So it comes as 13.1216. Sorry. So it comes as 421.84. 421.84 volt. So this is what secondary terminal voltage. Let us go for a second numerical. That is a 10 kVA 250 by 500 volt 50 Hz single phase transformer gave following test results. No load test is given. 250 volt 0.75 ampere 60 watt on LV side, and short circuit test result is 9 volt 6 ampere 21.6 watt, and it is on HV side. Find equivalent circuit parameters, refer to secondary side, right? So what is transformer voltage ratio? That is 250 by 500. So from here LV is what? Primary, and this is HB, which is what? Secondary, and K can be calculated here. K is 500 by 250, that will be 2, right? So from OC test, phi naught will be, no, OC test is conducted on LV side, that is primary side, so all parameters are on primary side only. Phi naught is cos inverse W naught by V naught I naught. W naught is 60, V naught 250 into I naught 0.75. So it will be cos inverse 60 by, so it comes as 71.34. Therefore IC and IM can be calculated. IC will be I naught cos phi naught. So I naught is 0.75 cos of 71.34. It comes as 0.75 cos 71.34. It comes as 0.2399, that is 0.24 ampere, and IM will be I naught sin phi naught, that is 0.7. So if I put it, it will be 0.71 ampere. So R naught and X naught, which are on primary side only, can be calculated. So R naught will be V naught by IC. V naught is 250 by IC 0.24. So 250 by 0.24, it comes as 1041.67 ohm, and X naught comes as B naught by IM 250 by 0.71. So it comes as 352.11 ohm. Now these are the parameters of primary side, and they are asking find equivalent circuit parameter, refer to secondary side. So let us refer on secondary side. So R naught dash can be written as K square R1 R naught, What is K? That is 2. 2 square 1 into 104, 1.67. So it comes as 104, 1.67. It comes as 4166.68 ohm, and X naught dash will be K square X naught, that is what 2 square into 352.11, 352.11 into 4, it comes as 1408.44 ohm. So these are the two circuit parameters referred on secondary side. Now AC test is conducted on HV side, and HV side is secondary side. So by default we will find equivalent circuit parameters referred on primary side itself. So ZE2 from AC test will be VSC by ISC. VSC is, you can see VSC is 9 volt and ISC is 6, and at an angle of cos inverse WSC 21.6 by 9 into 6. So if I equate it, it will be cos inverse 21.6 divided by 54. It comes as 0.6 plus J 1.374 ohm. So we got other parameters which are, therefore RE2 is 0.6 ohm and XE2 is 1.374 ohm. So circuit parameters referred on secondary side are calculated now. R naught dash, X naught dash, RE2 and XE2. Let us go for next numerical. 100 kVA 6600 by 330 volt 50 Hz single phase transformer took 10 ampere for 36 watt at 100 volt in a short circuit test. So short circuit test result is given. The values referring to HV side. Okay, HV side is here primary side. Right. Find voltage to be applied to HV side on full load, 0.8 power factor, lagging, leading, when secondary load voltage is 330 volt. Okay. So from AC test, right? AC test is conducted on which side? HV side, that is primary side. Primary side. So I can write here, I have voltage, short circuit voltage, short circuit current and power. So ZE1 can be written as VSC by VSC is 100, ISC is 10 at an angle of cos inverse. WSC is 436. 436 by VSC into ISC. So it will be 10 cos inverse 436 by, it comes as, okay, 4.36 plus J 8.999, that is 9 ohm. So we got RE1 and XE1. This is what RE1 and this is what XE1. Now they are asking voltage to be applied to HV side, that is primary side voltage they are asking at two different power factor, right? So if I find drop, I know circuit parameter, so if I find drop, then we can find applied voltage also. Okay, for finding drop we must know current. So let us find full load current on primary and secondary. So I1 full load will be, it is 100 kVA transformer, so 100 into 10 power 3 by 6600. So it comes as 15.15 ampere, and secondary full load current is again voltage is 330, so it comes as 303 ampere. 303 ampere. Now in primary side, what will be full load voltage drop? Full load voltage drop at given power factor at 0.8 power factor. First we are finding lagging, so drop will be written as, we know, I1FL RE1 cos phi, there is load power factor, plus I1FL XC1 sin phi. So put values. I1FL I am taking common, so 15.15. RE1 is calculated 4.36, power factor 0.8. If cos phi is 0.8, we know sin phi. Cos phi is 0.8, so phi will be 36.87 and sin phi will be 0.6, plus XC1 is 9 into 0.6. So if you do this calculation, 15.15 bracket 4.36 into 0.8 plus 9 into 0.6, so it comes as 134.65. 134.65 volts. So drop on primary side is this much. So available voltage is what? 6600 volt. So this 6600 volt on primary side is available after drop. So what will be supplied voltage? Supplied voltage will be greater than this. Therefore, voltage applied on HV side will be 6600 plus drop. So it is what? 6600 plus 134.65, so it comes as 6734.65 volt. So this is first answer.